So in benchmark 17, we're going to be solving two-step equations. But first, let's review one-step equations. Remember, you want to think opposite operation to solve an equation. So we'll do one of each. I would write down these examples in your notes and make sure you solve them with the video. So if we look at the one-step equation first, let's do x plus 7 equals 3. The opposite of addition is subtraction. So we're going to subtract 7 on both sides. The 7's cancel over here, so x equals negative 4, because 3 minus 7 is negative 4. So with an explanation, you want to explain why you subtracted 7. So we subtracted 7 because it's the addition inverse. Now if we look at the problem x minus 4 equals 21, remember there's two sides of the equal sign, the left side and the right side. Whatever we do to one side, we have to do to the other. So in this problem, the opposite of subtraction is addition, so we're going to add 4 to both sides. The 4's on the left side cancel, so x equals 25. When we explain, this step, our explanation would be subtraction inverse. Now if we have negative 3x equals 27, when you have a number next to a variable, like negative 3x, it's like saying negative 3 times x. So we want to, the opposite of multiplication is division, so we want to divide by negative 3. Those cancel. X equals negative 9. Our explanation for this one would be inverse of multiplication. And inverse just means the opposite. And the last one-step equation we're going to look at is a division one. So x divided by 4 equals negative 10. So on this one we want to multiply both sides by 4. Those 4's will cancel. So we have x equals negative 40. And the explanation for this one would be division inverse. So remember, when you're solving one-step or two-step equations, whatever you do to the left side of the equal sign, you have to do whatever you do to the left side of the equal sign, you have to do to the right side. You have to keep things balanced. So let's look at a two-step equation. When you solve two-step equations, you still have two sides of your equal sign. And this time we have to get rid of the 3 and the 4. We have to get this variable by itself. So we have to get rid of the 3, we have to get rid of the 4. So you always want to get rid of the number that's not with the variable. The 3 and the x are attached, the 4 is kind of by itself. So we want to get rid of the number that's not with the variable. So to get rid of the 4 on the left side, we're going to subtract 4 on both sides. Those 4's will cancel because 4 minus 4 is 0. So we're left with 3x equals 12, because 16 minus 4 is 12. So this is inverse of addition. Then we have to get this 3 away from the x, and now it's a one-step equation. So we can divide both sides by 3. The 3's will cancel because 3 divided by 3 is just 1. 1 times x is just x. So we're left with x equals 12 divided by 3 is 4. And this is the inverse of multiplication. So when I ask you to describe your steps, that's what you need to do. So if we have 3x plus 4 equals 16, and we said that x equals 4, we need to plug 4 back in for x to check our work. So 3 times 4 plus 4, and we need to see if it really equals 16. 3 times 4 is 12. 12 plus 4 is 16. So since both sides equal 16, we know we did the problem right. So always plug whatever your answer is back in for the variable. So let's look at another one. 2x minus 5 equals 11. So again, we have two sides of the equal sign, and then we want to get rid of the number that's not with the variable. So we have this 5 right here that we want to get rid of first. So we're going to get rid of the 5, and since it's minus 5, we're going to add 5. So we're doing the inverse of subtraction. So those 5's cancel because negative 5 plus 5 is 0. So we're left with 2x equals 11 plus 5 is 16. And now we have our one-step equation. So we have to divide both sides by 2, because remember this is 2 times x. The opposite of multiplication is division, so we're doing the inverse of multiplication. Those 2's will cancel. X equals 8. And then we need to check our work. So we're going to plug 8 in for x. We have 2 times 8 minus 5, and we need to see if that equals 11. 2 times 8 is 16. 16 minus 5 is 11. So we know we did our problems right. Next example we're going to look at is x over 4 plus 5 equals 10. So we still have two sides of the equal sign. This time the 5 is not with the variable. The 4 and the x are kind of attached. So we're going to get rid of the 5 first by subtracting 5. And that's the inverse of addition. That's ADD, add. So the 5's cancel. We're left with x over 4, we just bring that down, equals 10 minus 5 is 5. And our last step, x divided by 4, the opposite of division. So we're doing the division inverse. And we're going to multiply, since the opposite of division is multiplication. Those cancel. 5 times 4 is 20. And then we check our work. So we're going to plug 20 in for x. So we want to see if 20 divided by 4 plus 5 really equals 10. 20 divided by 4 is 5. 5 plus 5 is 10. So we know we did our work right. So let's look at another example. X divided by negative 3 minus 4 equals 5. So in this one we're going to get rid of the 4 because the negative 3 is with the variable. So we're going to start by getting rid of the 4. So we add 4 to both sides. Those 4's will cancel. We always want something to cancel if we're doing something to one side. So we're going to bring down the x over negative 3. And then 5 plus 4 is 9. So we did the inverse of subtraction. Now we have x divided by negative 3 equals 9. So the opposite of division is multiplication. So we're going to do the inverse of division. Remember, inverse means opposite. So negative 3 multiplied on both sides. Those will cancel. So x equals negative 3 times 9 is negative 27. And then we can plug negative 27 in for x to check our work. So we would have negative 27 divided by negative 3 minus 4, and we want to see if that equals 5. So negative 27 divided by negative 3, two negatives when you're dividing equal positive, so that equals positive 9 minus 4. 9 minus 4 is 5. So our answer checks out. Let's look at a two-step equation with a fraction. So we're going to treat it, it's the same steps as a whole number. This time you're dividing by a fraction. So we're still going to get rid of the number without the variable. In this case it's the 2. So we're going to do the opposite of addition and subtract 2 on both sides. So those will cancel, and that's the inverse of addition. And we're going to bring down the 1/2 times x equals 4. So instead of having a whole number times x, this time we have a fraction times x. So we use the exact same steps. Since we're multiplying a number times x, we divide by a half. These halves will cancel. Again, we always want something to cancel. and we're left with x equals, and then 4 divided by 1/2 is 8. And you can use your calculators, so this is the inverse operation of multiplication. So when you divide by 1/2, it's the same as multiplying by 2. So we can check our work. 1/2 times 8 plus 2, and we want to see if that equals 6. 1/2 times 8 is 4. 4 plus 2 is 6, so our answer checks out. So when you have that fraction here, if it's being multiplied by the variable, you still divide, just like you would for a whole number. So some things you need to keep in mind when you're solving equations is, one, you need to keep the equation balanced. Think of it as a scale. Whatever you do to one side, you have to do to the other side. You want to always do the opposite operation. So the opposite of add is subtract, and vice versa. The opposite of multiply is divide, and vice versa. And the last thing is, you always want to check your work. There's no reason to get these wrong if you check your work. Please start the worksheet. This is the end of Benchmark 17 video of two-step equations.